Hello students, today we will be discussing the free body diagram. Actually this free body diagram comes under laws of motion chapter. So first of all, let me clear you one thing, that what do you mean by free body diagram? A diagram showing in all external forces acting on an object is called free body diagram. Fine? Means a diagram which shows all the external forces acting on that object is the free body diagram. Fine? So in a specific problem, first we are required to choose a body and then we will find the number of forces acting on it, and all the forces are drawn on the body considering it as a point mass. The resulting diagram is called the free body diagram. Fine? So under this free body diagram, first we will be discussing the motion of the bodies in contact. Means some bodies are connected or some bodies are in contact with each other. Then how do we solve those kind of problems? So first of all we will be discussing that. So force of contact means what? When two bodies whose masses are let m1, m2, etc. rest on a frictionless surface in contact with each other, then the force with which one body presses the other body is called the force of contact. Clear? Now under this force of contact, we will first focus on the force of contact and the acceleration produced in the bodies. So in the board you can see, first is our case 1. Case 1 means when two bodies are in contact with each other. So first what we have chosen? We have considered when the acceleration produced in both bodies will be same. So if A be the acceleration, then we can calculate first the acceleration. Acceleration is force by mass. So total force applied on this body is F, and we have two masses m1 and f2. So m1 plus m2 is the total mass. Total force is F. So total acceleration will become F by m1 plus m2. Fine. So now we are giving a force on the bigger object. Let us also assume that the contact forces acting on this m1 and m2 be f dash each, because whenever you are pushing or pulling a body now, so since these bodies are connected together, so obviously the same amount of force, contact force, will be applied for the two bodies. So since force is given in that direction, so obviously the body will move with an acceleration in that direction. Fine? So the direction of acceleration is given, the direction of force is given. Here F dash will be the contact forces between two masses m1 and m2. So due to the contact of masses m1 and m2, let the applied force be F. Fine? So you have taken the applied force as F. Then for mass m1, now out of this whole figure we are just taking the free body diagram of mass m1. So what is happening in case of mass m1? You can see a force, external force is applied on mass m1. So due to the reaction force, another force, contact force F dash, will be acting in the opposite direction of the applied force being taken. So for mass m1, one force is given in that direction, another reaction force is coming in that direction, means two opposite forces are acting. So the net force will become F minus F dash. You can see in the board that it is given F minus F dash will be its net force, that is m1 into A. So from there we can calculate the F dash. F dash will be what? F minus m1A. So F dash is the contact force of the mass m1. So F dash will be F minus m1A. Now simply we can put the value of F. So F F is F, so M1 into A. So A we can write F by M1 plus M2. Clear? So it will be F minus M1F by M1 plus M2. Fine. So now doing the LCM, we can calculate F dash will become F into M2 by M1 plus M2. Fine. So means we can write what? We can write F dash is equal to M2 into A. So F dash is equal to M2 into A means M2 into A means force acting on mass M2. So this is the force on M2, means force acting on mass M2. Fine. So the contact force for this type of problem, we can calculate the contact force like this. Fine. Clear? Now for case 2, this is falls under case 1, and under case 1 it is, you can take a sub case or make it as Roman 1. You can make it as Roman 1. Roman 1 means when acceleration produced in both the bodies will be same. Fine. Now moving towards the Roman 2 case, means the sub case under this Roman 2 case. So Roman 2 means now it is become number 2. So if a force F is applied, if a force F is applied on the mass M2, on say M2, fine. Then acceleration, you can calculate what? Acceleration A will be total force by total mass, means F by M1 plus M2. So total force is F, total mass is M1 plus M2. So acceleration, we can take this. Now drawing the figure of that, so we have one bigger object, it is connected to a smaller object. So the contact force on the objects will be same. Now force is being applied in that direction, so obviously body will move in that direction with an acceleration A. Let us also assume the mass of the first body is M1 and the mass of the second body is M2. Since force is being applied in that direction, so obviously the body will move with an acceleration A in that direction. Fine. So if due to the contact of the masses M1, listen carefully, due to the contact of masses M1 and M2, let us assume the applied force is F double dash. Then for mass M2, what we can write? F minus F dash is equal to M2 into A. So means F dash will be F minus M2 into A. So simply F minus M2 into, now we are putting the value of A. A was F by M1 plus M2, means it will be M2F by M1 plus M2. Again we have to do the calculation, we have to do LCM. So LCM will be M1 plus M2 will be here. So now that will be M1 into F. Fine. Means we got F dash is equal to M1 into A. F dash, we are getting F dash is equal to M1 into A. That is the force of contact acting is our sub case number 2. If a force F is applied on M2, then what should be the amount of contact force? That will be M1 into A. Fine, clear? Now moving to the next section, that is case number Roman 3. Now it will be case number Roman 3. So in Roman 3, what is there? If three bodies of masses M1, M2, M3 are kept in contact, means now we are having three bodies M1, M2 as well as M3 which are in contact. So now making the figure, say it is one body, it is another body, this is another body, third body is inserted between these two. So let us assume it is M1, it is M2 and it will be M3. Fine. Now the contact force is being applied, say in that direction. Now contact forces between these two M1 and M2, it will be say F dash and F dash. So in between M2 and M3 there will be different contact forces. Let us assume the contact forces are F double dash. So there is one contact force between M1 and M2, there is another contact force between M2 and M3. Fine. So since the applied force is in that direction, so body will move with an acceleration A in that direction. Fine. So first of all, the acceleration produced, we have to calculate total acceleration is equal to total force by total mass, M1 plus M2 plus M3. It will be total force by total mass, that is the total acceleration of the system. So now if the force of contact between M1 and M2 be F dash, then what we can write, F minus F dash is equal to M1 into A. So now F dash will be F minus M1 into A, putting the value of A, M1 into A means F by M1 plus M2 plus M3. Fine, clear? So after solving this, you will get M2 plus M3 into F by M1 plus M2 plus M3. Fine. So means it will be equivalent to A into M2 plus M3. Fine. So this will be our F dash, this will be F dash. You can see this is the expression of F dash. Now we are going to calculate the contact forces between M2 and M3. So what was our contact forces between M2 and M3? So contact force between M2 and M3 be F double dash. So you can write F double dash will be M3 into A. F double dash will be M3 into A. So F double dash will be M3 into A, means M3 into A means F by M1 plus M2 plus M3. Fine? Clear? So for the body M2, what we can write? F dash minus F double dash will be its net force M2 into A, means it will be M2 into F by M1 plus M2 plus M3. Clear? See? See and tell me whether this part is clear or not. Fine. Hopefully it is clear to you. Now we will be going towards the second case, means that was our case 1. So under case 1 we have 3 sub cases. Then case 2. Case 2 means case 2 will be what? Motion of bodies connected together by strings. So connected by strings. Connected by strings. Under connected by strings, we are again making 2 sub cases. For 2 body, again we will do for 3 bodies. Fine? 2 bodies. It will be 2 bodies. Fine? Means we have one mass M1. It is connected with, let us assume the smaller mass M2. It is connected. There will be one tension in between these two. So let us assume the acceleration is in that direction, means one force is being applied on that direction. Fine? So for this, first step is to calculate the acceleration. Acceleration will be total force by total mass. Acceleration will be total force by total mass. Simple. Acceleration will be total force by total mass. Fine? Now you see, for the body M1, what you can write? For M1, what you can write? For M1 you can write tension is equal to M1 into A. For body M2, you can write F minus tension is equal to M2 into A, means from there you will get tension is equal to F minus M2 into A. Now putting the value of A, you can have F minus M2 into F by M1 plus M2. Fine? Means doing this you can calculate the tension. So now tension will be what? It will be M1 into F by M1 plus M2. So tension will be M1 into F by M1 plus M2. So this was the case when 2 bodies are connected by a common string. M1 and M2 are 2 bodies which are being connected by a common string, and one force is being applied on M2 directly. So in the given direction, the force is being applied on M2. So in between M1 and M2 there will be a tension exist in the strings connected between M1 and M2. And since the force is being applied on M2 in the right side, so obviously in the direction of the force there will be the direction of the acceleration. Fine? Now we will be moving towards three bodies system. It was the two bodies system, two bodies particle. So now sub case 2 will be for three bodies. For three bodies. For three bodies. It will be our case 2. Under case 2 it will be Roman 2 case. Fine. So now three bodies, let us assume this is one table. M1 is this, M2 is this, M3 is this. Three bodies are connected by two strings. There will be one tension, there will be one tension. And one force is being applied in that direction, so that the acceleration, net acceleration will be in that direction. So now let us assume the tension between M1 and M2 be T1, and between M2 and M3 the tension be T2. We have assumed that the tension between M1 and M2 is T1 and between M2 and M3 is T2. Fine. So total, first step is to calculate the total acceleration. Total acceleration will be forced by total mass, that is M1 plus M2 plus M3. F by M1 plus M2 plus M3 will be total acceleration. Now for mass, for M1, what we can write for M1? M1 we can write T1 is equal to M1A. For M2 we can write T2 minus T1 is equal to M2 into A. For mass M3 we can write F minus T2 will be M3 into A. Fine. Now we are getting three equations. Equations 1, equations 2, equation 3. To solve those equations 1 and 2 and 3, then you will get the values of T1, T2 and acceleration. Fine. So do it at home so that you can calculate. So I am just writing because I know the values. That is why I am just writing those values just to check whether your calculation matches with the same. That is why I am writing. But do it at home. Fine. So solving these equations now. Solving this equation, you will get T1 will be M1F by M1 plus M2 plus M3. T2 will be M1 plus M2 into F by M1 plus M2 plus M3. Fine. T2 will be M1 plus M2 into F by M1 plus M2 plus M3. Means it will be M1 plus M2 into A. So that will be our tension T2 and that will be our tension T1. So solving those equations 1, 2 and 3, you can get those expressions. Fine. Hello students, now we will be doing after case 1 and case 2, now we will be solving case 3. So case 3, in case of a rope lying on a horizontal surface. So under this we have taken a uniform rope of length capital L which is lying on a frictionless table, is pulled by applying a constant force. Fine. Now the length of this rope is capital L. The rope is AB. AB is our rope, and the length of this rope is capital L. So one force F is being applied in that direction. So if we have taken the small section here, so the length of the small section, let us assume the small l. So remaining distance will be capital L minus small l. So in that element, two tension will be acting in opposite direction. We have given one tension is acting on this wall, another section is acting on that wall. Fine. So let the mass of the rope be small m. Fine. So let us assume the mass of the rope is m and its length is given capital L. So mass per unit length will be what? Mass per unit length will be m by L. So it is mass per unit length m by L. So for that case we have to calculate first the mass per unit length m by L. So now if the small section is say PB, it is point P. So now if tension is T in the rope at a distance small l from the end B and acceleration of the rope is A. See what I am telling? The tension is the T in the rope at a distance small l from the end B and the acceleration of the rope is small a. Then the part PB. The part PB are seeing. The part PB we can write what? For part PB. For part PB what we can write? We can write F minus tension is equal to mass of part PB into acceleration. Mass of part PB into acceleration. So instead of taking the mass of this part, what we have to take? The mass per unit length. So it will become mass per unit length. It is equivalent to our mass into the distance PB. PB distance is small l. So that will be acting as the mass of this part PB and the acceleration is A. Fine. So that will be our F minus tension. Fine. So for the remaining section means for part AP, what we can write? The tension T is the mass of part AP, mass of part AP into its acceleration. Means mass of part AB will be m by L into its length is L minus small l into acceleration will be A. Fine. Tell me up to this whether it is clear. For part AB you are not seeing. Okay. For part AP the tension we can write part of mass AP into acceleration. So it will be mass, part of mass AP will be mass per unit length into its length. Into its length means L minus small l into acceleration. Fine. From part PB we have calculate F minus T is equal to m by L into small la. For part AP we have calculate tension is equal to m by capital L into capital L minus small l into small a. Fine. Now we have got what? Tension T is equal to m by L into L minus L into acceleration. Fine. So we can write L minus L by small l F minus T. Fine. Is equal to T. So from there T will be what? T will be 1 minus L by capital L into F. So for this case, to calculate the tension in the spring, just use this formula so that easily you can calculate, so that you can easily solve a numerical. Fine. So that was our case 3. So case 4 will be pulleys. So pulley, case 4 will be pulley. So for a pulley, let us assume it is very simple case, very basic case. Let us assume two bodies are connected, M1 and M2. So the weight of M2 will be acting downward, the weight of M1 will be acting downward. So in the strings there exists some tension. Fine. So from this figure it is clear that M1 is less than M2. That is why the system is going with an acceleration A. For the mass M1, acceleration will be acting upward. For mass M2, acceleration will be acting downward. So now think the free body diagram of M1. So what is happening in case of M1? Tension is being applied upward and its weight is being in the downward direction. But the net force is acting upward direction. Net force is acting upward direction. So which one will be more? Tension T1 is more or M1G is more? Obviously T1 is more. So tension is more than what? That is why it is pulled by the body. It means pulled by the body M2. So what we can write? Tension minus its weight will be its net force. T1 minus M1G will be M1A. So now going to the free body diagram of M2. Fine. So free body diagram of M2, if you draw, one tension is acting in that direction, its weight is acting downward, but the body is coming downward. So obviously the acceleration is acting in that direction, so its weight is more than its tension. So for this body we can write M2G minus tension is equal to M2A. Got it? So we have two different equations for M1 body and M2 body. Now solving this we can have tension is equal to 2 M1 M2G by M1 plus M2 and acceleration will be M1 minus M2 by M1 plus M2 into G. Fine. So after solving this equation you will get tension is equal to 2 M1 M2G by M1 plus M2. It will be the formula for tension and it is the formula for means for acceleration. So the reverse case of this body will be also possible. Means instead of this figure, if you would have a figure like this, now M1 is more than M2. Easily one can see M1 is now more than M2. So its weight will be this, its weight will be M1G. Tension in the strings will be same. So for M1 now for M1, so here obviously M1 is more than M2. Here M1 is more than M2. So for M1 it will be M1G minus tension will be M1A. For M2 it will be tension minus M2G will be M2A. Then also by solving you can calculate the values of acceleration as well as tension. Fine. Now for case 5 we will be having one pulley connected. Here two bodies are connected, say M2 and M3. M2 and M3 are connected. Here one body M1 is connected. So its weight will be M1G, its weight will be M2G, its weight will be M3G. Let us assume the tension between M2 and M3 be T2 and M1 and M2 be T1. Fine? Clear? What we can write? For mass M1, what we can write? Tension T1 minus M1G is equal to M1A. Because it is in the upward direction. The acceleration is in the upward direction. For M2 and M3 both, the acceleration will be in the downward direction. Fine? Now for M2 we can write what? M2G minus T2, no plus T2 minus T1 is equal to M2 into A. Fine? So for M3 we can write M3G minus tension T2 is equal to M3. So we are getting three equations for this case number 5. So solving this equation, obviously you can get acceleration. Acceleration will be m2 plus m3 minus m1 by m1 plus m2 plus m3 into 4 into g. It will be acceleration, and putting those values means putting the value of acceleration on equation 1, 2 and 3 we will also calculate. You can also calculate the expression or the means formula of T1 and T2. Fine. Then moving towards the next case, that is case 6. Case 6. Case 6. Suppose we have a table. It is one table. On that table we are putting an object M1 with connecting a pulley, another body M2 which is hanging. So its weight will be M2G, tension in the string will be T. Fine. Now we have assumed that here M1 is more than M2. If M1 is more than M2, for M1 we can write M1A is equal to tension, because M1 don't have any weight, because it is putting on the table. So no weight is means you have to calculate, you have to take means its weight as null, zero weight. So only the tension will be applied on that body M1. So directly you can write M1 into A is equal to tension. Fine. For M2, obviously since M1 is more than M2, so obviously it will be moving upward direction. So the tension minus its M2G will be its M2 into A. So solving this, you can get the expression of tension as well as acceleration. Fine. So now if M2 is more than M1, then we can get M2G minus tension will be M2A, and M1A will be tension. Fine. So solving this now, you will get acceleration will be M2G by M1 plus M2. Acceleration you can calculate M2G by M1 plus M2, and tension also you can calculate. Tension will be M1 M2G by M1 plus M2. Fine. So tension will be M1 M2G by M1 plus M2, and the acceleration will be M2G by M1 plus M2. Fine. So now we have considered two cases, two sub cases, when M1 is more than M2 and when M2 is more than M1. So it is the expression, maybe the same expression you can get, the expression for tension and acceleration for this case. Fine. Now moving towards the next case, case number 7 it will be. So in case 7 we have similarly a table. So on that table we are putting an object of mass M. Here two pulleys, one mass is connected M1 here, another pulley mass is connected M2 here. So its weight will be acting downward, M2G. Its weight also will be acting downward, M2G. This is a table, frictionless table. So let us assume the tension is T1 here and tension T2 is for mass M2. So now we have assumed that here M1 is more than M2, means the system will be accelerated. M1 will be accelerated upward and M2 will be accelerated downward. So since the M1 is moving in that direction and M2 is moving in that direction, so which tension will be more, T2 or T1? Obviously T2 will be more than T1. So for this body M, capital M body, what we can write? T2 minus T1 will be its net force. Fine. So it is the equation for capital M. Fine. Middle object. Since acceleration is in that direction, so for M2 For M2 we can write what? We can write M2 G minus its tension T2 will be M2 into A. So for M1 what we can write? Tension T1 minus M1 G will be M1 into A. Fine. Since the body M1 is moving upwards, so obviously its tension T1 will be more than its M1G Mg component. Fine. So solving this now, you will get the expression M1 minus M2 into G by M1 plus M2 plus capital M. It will be the expression of acceleration, and then also you can calculate the expression of tension T1. T1 will be M1G into 2M2 plus M by M1 plus M2 plus M. It will be the expression of T1. Similarly, T2 will be M2 into G by 2M1 plus M by M1 plus M2 plus M. So solving, you can get the expression acceleration T1 as well as T2. Fine. So now moving quickly towards the case 8. So in case 8 we have one inclined plane. So we have pulley connected, say M1. So its weight will be M1G, its tension is T, another body is connected. So let us assume the mass of this body is M2. So it is an angle of inclination theta. So we can make the component, here. So its weight M2G will be acting downward, it will be theta, so it will be M2G cos theta. In that direction it will be M2G sin theta. It will be tension. Fine. So if the body moves in that direction, means with an acceleration A, then its M2G sin theta will be more than its tension. So we can write M2G sin theta minus tension will be M2A, and for M1 we can write tension minus M1G will be M1A. If the body moves in the upward direction, now what we have assumed? We have assumed that M1 is moving upward and M2 is moving downward. So instead of this, if M2 is moving upward, M1 is moving downward, then the equation will be look like this. Acceleration upward is acceleration downward. Clear? So tension minus M1 M2G sin theta will be M2A, and M1G minus tension will be M1. Then for M1 we can write this, for M2 we can write this expression, tension minus M2G is equal to M2A. Because now what we have taken that the body M2 is moving upward and M1 is moving downward. So obviously since M1 is moving downward, so M1 is moving downward with an acceleration A. So obviously M1G will be more than its tension. And since the body M2 is moving upward, you can see from the figure, M2 is moving upward. So obviously tension will be more than M2G sin theta component. So obviously for M2 net force will be tension minus M2G sin theta, and for M1 net force will be M1G minus tension. Fine. So you can solve the values. You will get acceleration as M1 minus M2 sin theta into G by M1 plus M2. It will be the acceleration, and tension you can write, tension will be M1 M2 into 1 plus sin theta G by M1 plus M2. It will be the expression of tension, and it will be the expression of means acceleration. Fine. So it was our case 8. So now for case 9. So case 9, what we have taken? We have taken two inclined plane. This is one plane, this is another plane. So M1 and M2 are placed on the two inclined surfaces. It is connected by a common string. So tension will be same since these two bodies are connected by the same string. So tension will be same, T and T. Now M1 has a horizontal component M1G sin theta 1 because we have chosen two different slope of these surfaces, theta 1 and theta 2. So for with theta 1 surface, M1 is moving. So M1G sin theta 1 will be its horizontal component and M2G sin theta 2 will be its horizontal component. Now what we have assumed that M1 is more than M2. Since M1 is more than M2, so the body will be acceleration in the direction given in the figure. So M2 will be moving upward and M1 will be moving downward. So since M1 is moving downwards, obviously its M1G sin theta component is more than tension. So for M1 we can write what? M1G sin theta 1 minus tension is equal to M1A. And for the M2, see, it is moving upward. So tension is more than M2G. So that case we can write tension minus M2G sin theta 2 is equal to M2 into A. Fine. So solving this we can get the expression acceleration and tension. So acceleration will be M1 sin theta 1 minus M2 sin theta 2 by into G by M1 plus M2. It will be the expression of acceleration for this case. And tension, if you want to calculate tension will be M1 M2 into sin theta 1 plus sin theta 2 by M1 plus M2. So it will be by M1 plus M2. So basically one G will be there. So tension will be M1 M2 sin theta 1 plus sin theta 2 into G by M1 plus M2. Fine. So obviously we can also take M2 is more than M1. So if you reverse the direction of the acceleration, then also you can solve this type of problems. When M2 is more than M1, then the direction of acceleration for M1 will be upward, fine, and direction of acceleration for M2 will be downward. So for M1 we can write tension minus M1G sin theta 1 is equal to M1A. So for M2 we can write M2G sin theta 2 minus tension is equal to M2 into A. So solving this we can get the similar values. In acceleration it will be G M1 sin maybe theta 2 minus M2 sin theta 1 by M1 plus M2, and tension will be same. M1 M2 into sin theta 1 plus sin theta 2 by into G by M1 plus M2. Fine. So it was our case 9. So now we are moving towards case 10. So in case 10 we have say a table. One pulley is connected. So one spring is there. After the spring we have one body. Let us assume the mass of this body is M2. And we have another body. Let us assume the mass of this body is M1. So tension will be applied in that direction for M1 and tension will be acting in that direction for body M2. So obviously since it is hanging, so its weight will be M2G. Fine, we have taken the expansion as x here. Fine, expansion is x. So similarly, you can solve the value of tension first. Tension will be similar to case 5. Similar to case 5, you can see the case 5. So similar to case 5, we can calculate first the expression of tension. Expression of tension will be M1 M2 G. You can see case 5 for this M1 plus M2. I am directly writing this. So from case 5 we can write tension is equal to M1 M2 G by M1 plus M2. Now if x is the extension, F is the extension in the spring. Where is the spring? Here is the spring. So then T we can write Kx. How? We know that the force applied on a spring is directly proportional to the displacement. Force applied on a string is directly proportional to the displacement. So you have a spring. Now you are giving force to stress the spring. So obviously after applying the force, the length of the spring becomes like this. So this is our extension x. Whenever you remove this force, obviously spring will get its original size and shape. Means amount of force given to a spring is directly proportional to the extension in the spring. As soon as you are removing the amount of force, obviously spring will get its original size and shape. Means force directly proportional to the displacement. So tension is nothing but a force. So tension on the spring will be force of spring. So tension directly we can write Kx. Fine. So tension is Kx. So obviously the extension, if required, if asked in the question the value of extension, so extension you can take K by T, T by K. So extension will be directly you can write M1 M2 G by M1 plus M2 into K. So extension for this case will be this. Directly you can solve this with the help of this. Means expression. You are not seeing? Okay. So extension x will be M1 M2 G by M1 plus M2 into K. Fine. So that's all. That was the different cases for solving the pulleys as well as for rope, horizontal rope, as well as bodies connected by a common string or by giving some common force between two bodies, three bodies, like this. So hope you have understand. So just go through all these topics, all these cases, so that if means you can understand more precisely. If still there exists some doubts, you can directly ask me, you can directly WhatsApp me. Fine. So that I can help you. Okay. Thank you for watching.